Assalamualaikum warahmatullahi wabarakatuh. To Dr. Razali, my name is Ahmad Shafiq bin Azman, and this is assignment that I will present about the Hebbian method. So, for the first one is we have a input which is x1 and x2, and the class which is a and b. So I will present a as 1, b as a 0. So we have y, w1, w2, b and alpha. So for the alpha, I set the value is 0.6. For the initial value w1, w2 and b, I set as a 2, 2 and -1. So to get the first value for this column, we must use this two kind of the formula, which is we want to find the w1 for this value, which is 2.6. So to find the value of 2.6, we must use this formula, which is w new equal to w old plus alpha multiplied with x multiplied with y. Okay, so w old we must take the initial value. So the x and y, we take this x1 and this y, because we want to find the w1. So if we want to find the w2, we must take the x2 and y. So the b, also we use this formula, which is b new equal to b old plus alpha multiplied by y, which is we use the old previous value, which is -1, multiply plus with alpha 0.6 and multiply with 1, which is y for this part. Okay, for others part, we must repeat the same way to get the value. And lastly, we can, for the last part, we get the 3.2 for w1, 3.2 for w2 and 0.8 for b. Okay, so next, how to represent the Hebbian neural method in the graph. So we must find the gradient, y-intercept, x1 and x2. Alright, so this part I will explain in Notepad, which is the right side that I have wrote just now, which is we must the formula is x1 multiplied with w1 plus x2 multiplied with w2 plus b more than and equal to y, because y is the output. So we must take the 3.2 and 0.8, the last value of the w1, w2 and b, and insert in this equation. So we will get 3.2 x1 plus 3.2 x2 plus 0.8 equal to 0.6. Alright, so the 0.6 is actually the value of our alpha. So, and then we calculate to and then we calculate the equation to get the m, which is represented to the gradient, which is m equal to x1 over x2 equal to -3.2 over 3.2 equal to -1. That's why we get here our gradient is -1. So to find the c-intercept, we must use this kind of formula, which is y equal to mx plus c, that which is this formula is used to calculate the straight line. So we must find the c equal to y equal to mx. So y, which is y over x equal to m equal to x1 over x2. So x1 is the y and x2 is a x. That's why I put the value is 3.2 minus gradient, which is we get -1, and multiply with 3.2, the value of x 3.2, which is in the Excel I present it as a W2. Okay, for for, for the example, for the first example, I will present the x1 equal to 1, x1 x1 equal to y, x2 equal to x. So I give the example value, which is x1 equal to -5, and we must find the value of x2. So by using this formula, which is y equal to -1 equal to m x2, which is x plus c. So we arrange this kind of the equation to get the x1 minus c equal to m x2. So x1 is -5 minus c 6.4 here equal to -1, which is our gradient, times x2, because we want to find the value of x2. So after that we calculate, and then we get the value of x2 equal to 11.4. So it's same as in the Excel. So we just change the value of x1 here with -4, -3, and so on. The value is must presented to the gradient because the gradient is -1. So the value must go downward with with space of the -1. So -4, -3, -2, -1, and 0, and so on. So and then we presented the graph by x1 and x2. Alright. Okay. For the next, I reshuffle the data, which is the initial value for W1, W2, and B. I use the value of 1, 1, and -1. But the alpha is remain constant, which is 0.6. So to find this value, this all value, we must repeat the same step as the previous one that I show to you, and we can get all the data in this graph. Alright, for example, if I change the value of alpha, I change is 0.4. Okay. So all the value in this table will be also changed, and the graph also be changed. It's more to beyond to left side. So if I increase the value of alpha, which is 0.8, the value also change, and the graph of the straight lines will move rightward. So that's all for me. Thank you.